Hi, this is Swapnil Bharti and welcome to this special edition of TFiR Insights. We are covering Red Hat Summit remotely, and today we have with us Chris Wright once again, Senior Vice President and Chief Technology Officer at Red Hat. So let's talk about your keynote. Of course, this time we did not see it in person as we would have. So tell us, some of the highlights of the keynote, because what I do realize that, you did talk a lot about the importance of data and the role of hybrid cloud. So talk a bit about, why suddenly you're talking about data and how does it also change the whole concept of data center? Because in today's world, especially with this crisis, a lot of people have started to think about moving to the cloud because, managing their own data center can be challenging. So talk about not only from the point of view of this keynote, but also in general where you see the industry will be moving.
So we'll start with data, and the data piece is reflective of just the exponential growth of data that's been going on for quite some time. You'll hear various analyst stats that are always staggering, and it's up and to the right. It's things like, in the last couple of years, 50% or more of the world's data has just been created, and so when you put it in that context, and then you look at growth of just consumption of cloud, they're directly correlated. And it's not surprising to me that you see that relationship, because increasingly, it's not just applications that are building value for businesses, it's data. And it's not just the data, but it's the information that's trapped inside that data. So how can you think of it as extracting information from that data? How can you extract information to make the most valuable decisions for your business? That thinking, that thought process is what's driving, I think, a lot of businesses to look at how they invest and what types of applications they build. We would often call them intelligent applications, or applications that are infused with, say, a data model. You make a query to an inference engine to recognize a pattern or look for an anomaly, or make a recommendation for an end user. Those things are high value types of applications. So bringing data in, one of the things I love about Kubernetes as a platform is it's bridged the gap between application clusters and data clusters. They tended in the past to be very separate. Today we're able to bring those together, common platform, and then take it one step further, give data scientists tools to really rapidly innovate on data models. How do you make a more efficient predictive model? The same iteration that you might do as a developer, pushing out code changes, you can do as a data scientist, pushing out model changes. And when you combine those two things together on a common platform, we're seeing our customers really make serious advances for their own businesses in terms of what's possible, which is cool. It's really fun. It's a fun thing to see. Well, I think it's going to be a very, for one thing, just the human part, like really acknowledge the challenge that we're going through, and especially for people who are directly impacted, this is not an easy time. When you think about my daily life, I'm working from home. That is a new norm that we're in right now. So understanding just a distributed workforce, I don't think is a temporary reality. I think this has the potential to really have long-term impacts on how we consider how we work together. Red Hat is, deeply engaged in open source communities. We're a very distributed organization. So for us, there's some learnings. It's a little bit more natural to us than it might be for some other businesses. Doesn't mean we're perfect. We still have a lot to learn. But I think on the other side of this, we'll experience a new way of operating together. And frankly, I do a lot of travel. If I can reduce some of that as a result of this, that's a positive. I think that's good, not just for me as a person, but you could go global in the climate and all those things. I think there's some interesting things that come out of that. When you think about the data center, there's a couple of different tacks that people are taking. One is try to accelerate motion to the cloud. Maybe they just don't have the access to their physical data centers. Another is, with the economic uncertainty, there is potential cost associated with migration to the cloud. If you've got existing infrastructure that you've already invested in, you've depreciated the capital expense, that's like an asset that you can leverage. And so we also see folks looking at how can we leverage what we have, maybe thinking in terms of extreme automation to create more operational efficiency, especially with some economic uncertainty. So I wouldn't say it's all one thing or the other. Not like everybody's rushing to the cloud. In fact, in certain scenarios, an application that's not cloud native running in the cloud could be more expensive. If you're not sort of scaling it and stopping it and starting it appropriately, you can just run up a bill that you weren't anticipating, which may not exist when it's in your data center and you own that infrastructure. So I just think there's maybe, if anything, it really highlights what the value that a hybrid cloud brings. We have a lot of customers talking to us about using Red Hat OpenShift as a bridge between their on-premises infrastructure and their interest in public cloud. And I just don't think that goes away. If anything, it's kind of accelerated. So very interesting time. And again, my heart goes out to anybody who's directly impacted, because this is not an easy experience.
A lot of things will change. Companies will also, save on office spaces. Red Hat is, I think, you have a lot of workforce which work remotely from home. A lot of things will change, but that would also mean there will be more strain, more stress on network as well. So if you look at 5G, we need it more, or that would also have an impact on edge computing. At the same time, you may not want to move a lot of data because of latency or whatever reasons, to the data center. So how would that also kind of affect the kind of, computation of that data, at the edge or, at the user's devices?
It's a great question, and we work a lot with the telecommunications industry. A lot of our customers are communication service providers or telcos, and their networks are under amazing strain. I mean, you see statistics like 100% growth in capacity or bandwidth utilization. It's really remarkable, depending on your geography around the world. It's really remarkable how well the telco networks have withstood this increased capacity demand. Again, some geographies have struggled more than others. In the U.S., it's been, it's not perfect, but it's been pretty remarkable if you consider just such a fast and sudden change. But all of the focus on investing into expansion of the network for the service providers is just sort of accelerated. And when you look at the potential for technologies like 5G to bring latency down and bandwidth up to reduce the distance, so to speak, to the data sources, there's definitely a strong push for that. We're working already with service providers to build out 5G networks. At Red Hat Summit, we had a discussion. We had Verizon on stage talking about what we're doing together with them, and it's just an example of how we're helping the networking teams evolve their networks. And in that evolution, there's a software platform at the bottom that helps it be more cloud-like and adjust to these really dynamic workloads. And then edge computing, it's not a new concept. We've been talking about it for a number of years in the industry. Some of the examples trying to leverage the low latency, high bandwidth, high connection density of 5G are futuristic feeling. So you hear AR, VR, you hear autonomous vehicles, drones. In a world that we're in today, we've got this highly distributed workforce. We're all connected through video conferences and streaming video content. There's opportunities right there for enhancements in the network to improve either reduction of bandwidth and not killing the experience of the user or service, but also an augmented reality type of experience can improve the human experience. So as we're more remote, looking for ways to stay connected, that technology suddenly feels more like the impact is more easier to understand. And then you take it one step further and say, today our medical world is just being pressured with unprecedented need. Telemedicine, as a concrete example of a way to leverage a next generation network, becomes a really palpable, valuable thing that the infrastructure that we're putting in today helps build that kind of that future, which doesn't, maybe if a year ago it felt a little bit science fiction, today it really feels meaningful, and it's well within our grasp. But we're already building some of these technologies and solutions today.
But all these workload also mean that, yes, you can run your workload on this device, but to create that content, you need much more processing power, whether it's VR or AR, whatever it is. So what kind of advancements are happening in the computing world? We have been thinking about or talking about quantum computing for so long. What realistic work is going on there? We all know that we will never be running a quantum computer on more phones. It's a totally different kind of world altogether. You have to cool it down to so much. But talk a bit about that industry, and are you doing any work with some of the quantum computing, either research labs or companies?
So first of all, it's a fascinating space. Quantum computing, you could put it in the buzzword category of is it just this sort of speculative hyped technology? And it's still very early days, even though decades of research have gone into the state of the art for where we are today. It's still very early days in terms of the practical applications and the scale of how folks could manufacture and build quantum computers. But the advances are meaningful, and today quantum computers are actually capable of doing useful work. In fact, there's already quantum computer manufacturers engaging with customers to do some of the early just experimentation and see what's possible. The thing that I think is interesting is when you look at the core principle of a quantum computer is operating on a qubit, which, unlike a digit, which is either a 0 or a 1, a qubit is more of a quantum mechanical statement about, yes, it's both a 0 and a 1 with a probability distribution, and harnessing that kind of complexity gives rise to an exponential growth in capabilities based on the number of qubits that you have. So at a relatively small number of qubits, you start to be able to do things like model things at the scale of, say, the number of atoms on the planet, or even the number of atoms in the universe, which frankly boggles my mind. I mean, it's hard to get your head around that. And you get into these interesting conversations where you realize that to build a digital or classical computer, the problem would either take all the atoms on the planet or require 10,000 years of compute time in order to make a dent in the problem domain. Translate that to a quantum computer, which can do this sort of sophisticated modeling through the quantum states that are captured in the qubit. You can reduce those times to something that's meaningful in our lifetime or even in hours. And you look at the applications mostly to major modeling, complex modeling efforts. Things like molecular structures, understanding the way different molecules interact in the physical world could give us major advances in material science. Maybe we could discover a better lithium-ion battery. Kind of feels like a mundane application, but think of how much we rely on batteries and what does that mean to our life. I mean, so I think put it in a medical context, understanding whether it's cancer discovery or cracking Alzheimer's. I mean, these are really big, major, challenging problems that require complex models that we approximate with classical computers. If you can really model those with a quantum computer, we can make major advances that would be impactful just at a human scale across the globe, which is it's a humbling notion. It's really exciting. It's still a few years away in terms of practical application of technology, and I don't think it replaces the classical computer. There's a set of tasks that are just better suited for that processing unit. Just like you look at machine learning, you've got a vector processor or a GPU or a TPU, primed for that task. Quantum computing can tackle another set of tasks. So I think heterogeneous computing is the future, and this is just an example of where the future could take us. It's really, it satisfies your intellectual curiosity in a way that few things do. So I'm really excited about it from that point of view.
Chris, before we wrap this up, anything else you would like to share? Though we did not have those hallway track where we were interacting with a lot of people, so most of the things are happening is, internal dialogue is going on.
One of the things that I enjoyed being able to talk about at the summit in my keynote was it's, data that we touched on in the beginning. It's how we build a platform that enables Red Hat ourselves, as well as our customers, to leverage that data to make kind of more interesting observations and insights into their businesses. So data plus a platform helps you change your business. What's exciting to me about that is those business level changes are actually helping our customers advance industries. And the applications that we talked about include things like safer, faster processing of security checkpoints through an entire airport, so that we have fewer exposures to things like a COVID virus, but not sacrificing security through facial recognition techniques, or better ability to predict the manufacturing flaws associated with vehicle production to make safer cars. And things that really have major impacts. The 5G networks that we're rolling out, what we were talking about earlier, these have real major impacts. And maybe the parting thought from me here is, if you look at the combination of a smartphone, a 4G network, and cloud computing, 10 years ago, those were relatively new. When you combine those things together, it gave birth to whole new businesses that then we couldn't imagine, now we depend on entirely. We're at a point in our history with device proliferation, producing and consuming tons and tons of data, 5G networks, and edge computing, where the ingredients are coming together to build that next wave of innovation that today is hard to imagine what it'll be like in 10 years, but we can see that that's what's happening. We're bringing these things together, and it makes it really fun, it makes it really exciting. So look forward to the next conversation where we can tap in one step further to exactly what those innovations are, what we're building.
Yeah, very right. And I think that is making it hard for science fiction writers, because whatever they could have thought is already a reality, to be honest.
That's right.
Chris, once again, thank you for your time. And as I said, we look forward to seeing you in real at some point.